Thank you, everybody, for joining us this afternoon, for taking some time out of your day, and welcome to the 2021 Vermont Organics Recycling Summit, organized by the Composting Association of Vermont in partnership with the Vermont Agency of Natural Resources. This year's summit is being held during the International Compost Awareness Week, which is the largest and most comprehensive education initiative of the compost industry. For those who don't know me, I'm Natalia Duarte, Director of the Composting Association of Vermont. I'd like to give a huge thank you to all of our sponsors this year. These include Community Bank, Eco Products, Vermont Natural Ag Products, Addison County Solid Waste Management District, AgriLab Technologies, EcoPixel, Nature Cycle, the Vermont Produce Program from the Agency of Agriculture, Food and Markets, and the Eco-AmeriCorps program from the Department of Environmental Conservation. Before we get into today's program, there's just two announcements I'd like to make. One is this statewide art challenge that we're doing. The Composting Association of Vermont worked with Paul and Winsong Kervik to create a 2021 food scrap story calendar, which featured photographs of interesting designs that emerged in their food scrap bucket over the year, and they took pictures. Inspired what she saw in her grandmother's calendar, 4-year-old Neoma created her own food scrap art here in these bowls. And we were really motivated by all of this creativity, and there was a lot of interest from multiple partners as well. And so we're launching the statewide Food Scrap Arts Challenge as an outreach and education activity. This VORS is the formal launch of this. And then submissions will be featured on the CAV website, and some will be selected for our 2022 calendar. And you can learn more on the CAV website under projects. And now on to today's virtual tour with Q&A. This is the inaugural virtual tour for VORS, as far as I'm aware. And it's highlighting Vanguard Renewables Anaerobic Digester at Goodrich Farm. The virtual tour will be followed by Q&A with Billy Conley, the Vermont Organics Market Manager, and Lance Butler, who is the Facilities Manager for the Goodrich Farm Digester. And with that, I'm going to switch what I am sharing. And there is no sound at the very beginning, so sorry about that.
Hello, I'm Lance Butler. I work for Vanguard Renewables. I am Facilities Manager here at the Salisbury 81 project in Salisbury, Vermont. We are here at the Goodrich Farms, and this farm is milking 800 cows currently, with plans to grow to 1,000 cows. And we will be taking about 100 tons of their manure every single day and processing it in our anaerobic digester. So all the manure on the Goodrich farm is processed through a series of screw presses, and these mechanisms will separate the fibers in the manure from the liquid. The fibers are conveyed out into some bays, where the farm will again use that fiber for bedding, and the liquids are pumped directly to feed the digesters. All right, here we have essentially manure fibers that have been separated from the cow manure. The farm is going to use this for bedding of all their cattle and all their barns on this farm. And of course, they'll clean the barns. This will go back into the manure stream, and then we'll separate it again. So this is a beautiful closed loop and sustainable method for farmers to bed their cattle. And the cows love it. So the farmers love it. And what we found is actually we usually, the somatic cell count of the cows in the milk quality, the somatic cell count goes down and the quality goes up.
Here we have the hydrolyzer tank, and this is where food waste comes in, and we can take both solids into the solids pit, into the solid chute, and liquids that get fed in through these hoses. And the hydrolyzer, 264,000 gallon tank, and the food waste and liquid waste gets mixed together here, has a residency time of about 5 days before it then gets pumped in through underground piping system into the anaerobic digester.
There you go.
And then here we have liquids inlet and a screen to capture contamination. And hopefully you can see what we see, and that is the material underneath is actively moving, being mixed around inside the hydrolyzer tank. Here on top of the hydrolyzer tank, we have two deck-mounted agitators. They have propellers down inside the tank that move the material around and keep mixing it up. Grizzly bars here to prevent people from falling in.
Behind me is the anaerobic digesters. This is where all the magic happens. There's actually two digester tanks where almost 1 million gallons of slurry is swirling around in each one. These are complete mix digesters designed with a raceway in the middle to allow for complete mix with only 2 mixers, and the inertia just creates a better mix. And as you can see inside of the black bubbles, that is all biogas storage, and we're producing quite a bit right now. This is where the manure in the food waste are fed in to the digester, and the bacteria consume the food waste and manure to become biogas. Here we have ferric chloride, in which we use to control our hydrogen sulfide levels, a byproduct of biogas production. What happens is this ferric chloride will precipitate the sulfur before it becomes hydrogen sulfide gas. And we do this to help with the gas upgrading process to end up with a cleaner product. Behind me in this blue container, we have a combined heat and power generator. We are completely off-grid electrically at this site, and we are burning gas to produce 800 kilowatts of power that will fuel this power this entire site. This is the generator that came out of the Czech Republic from Tetum, and that's pretty much that. This will also provide heat for the entire site, so we're capturing the heat off the water jacket and off of the exhaust. It provides more than enough heat for the entire site. Keeping the hydrolyzer tank at 108 degrees, keeping both of the digesters at 102 degrees. So this is where the heat from the combined heat and power generator is being distributed. So through these pipes directly from the generator, the glycol heating water swirls around, and all these pumps are pulling it and sending it to heat the various tanks and locations on site. And then we also have a boiler in case our generator ever goes down and we don't have heat for a while. This will supply the heat temporarily while we're down. Alright, here is our motor control center. So all the breakers, VFDs, and the panels that's controlling all the mixers, pumps, and various equipment around the site. And over here you have your PLC with the instrumentation communication connected into a SCADA computer, which displays all the controls. And I also have remote access to this, where I can start pumps, monitor levels, look at trends, and keep the digester running happy. That'll do. Over and out. This here is a small chemistry lab that we use to collect samples and run chemistry on the digestate from the digesters every single day by measuring the pH and doing a titration and extrapolating the results. We're able to tell the digester health and see how the feeding is correlating to the bugs and how they're keeping up with all the food waste and manure that we're feeding, and we can make adjustments as needed. And yeah, one of the most key components here, digester health.
We have a standby generator in the event we need it.
Now I'm going to show you the DAF system, the dissolved air flotation system. Here we have the inlet pipe, which is bringing the liquid digestate from the digesters. And this first will go through a trommel screen, which is basically a large rotating drum with 1/4-inch holes. It's going to filter out any large fibers, large solids, contamination, and anything like that. The liquids will pass through the screen, and it'll come through this pipe, flowing underneath us into this vessel over here. As it's traveling into this vessel, it's being circulated and injected with air. That's why they call the dissolved air flotation system. The liquid is also being mixed with a polymer. The polymer is going to bind with phosphorus and bind with solids, and that's the purpose of this system, is to remove phosphorus. So, and then the air is going to, the dissolved air is going to cause that the binded solids and polymer to float to the top and create this flocculant, they call it. And these skimmers will be skimming the flocculant as the liquid is added, polymer is added. The flocculant will be skimmed over the edge into this hopper where it passes through a series of screw presses. It dries out the solids further, and from there they'll be conveyed along and out to be stored, and that is what we call a phosphorus cake. And from here, the liquid portion will be sent directly to storage, where it eventually will be land applied, with up to 80% of the phosphorus removed. This process allows for the farm to actually increase its herd size and its viability, because now they can manage their phosphorus much more conveniently and spread more effluent on the fields, spread more manure on the fields, and it's a win-win for the farm and the state. Here's a quick shot of the phosphorus cake, where it's conveyed from the DAF system into a roll-off container where it is collected and sent off-site. After the food waste and manure has spent an average of 30 days in the digester and then processed through the DAF system, it is stored in the large slurry store tanks behind me. Each of these tanks can hold up to 2.5 million gallons. And we also have satellite lagoons for any extra effluent that we'll be storing to be spread on the fields by the farmers and grow crops for the cows and continue our beautiful biogas circle of life. From the digester, these two blowers here are pulling the gas into the biogas upgrading system. First step is the gas needs to be chilled to condense the moisture out of the gas to then be further processed. From there, we'll go into these giant vessels, which will be used to remove any H2S that is in the biogas, that is hydrogen sulfide. From there, the gas will be compressed to be pipeline ready, and then go through a PSA system, which stands for pressure swing absorption. In that process, it cleans up the rest of the constituents of the gas, and it will be roughly 98% methane and be ready to put in a pipeline. And it will travel to the pipeline directly from this facility over to BGS's gas line.
And that pipeline starts here.
Believe it or not, methane is a far more potent greenhouse gas than even CO2. So any release of methane gas to the atmosphere is undesirable. So here we have a flare that will combust the biogas and make it much less harmful to the environment than a raw biogas release to the atmosphere. And right now we're temporarily running this flare, but once we have the biogas upgrader up and running, this flare will only be used in emergencies.
So here we have the project from cow barn to the screw press room. Building with the logo on it. That's the phosphorus removal system. Next to that is the gas upgrader. Those are the anaerobic digester tanks. Combined heat and power system, the green building, the blue one that you can't see. And just in the foreground of the combined heat and power is the hydrolyzer tank, the intake for the food waste. From the anaerobic digester, the gas upgrader system to the pipeline. This is the interconnection point and equipment for Vermont Gas Systems. Make sure that the gas flowing into the pipeline meets all the specifications before it's distributed to gas users down the line.
Thank you very much for that video. That was really great. Lance and Billy, you did an awesome job. There was a lot to see there. And I also just want to give a real shout out and acknowledge that when we were hoping to potentially have some in-person small tours for this, but of course we still can't quite do that. We're not quite there. So we switched to this virtual format and really asked a lot of our participants who are not professional videographers, but produced an awesome video nonetheless, where we could really see the whole site. So now I'm going to open this up to Q&A. You can type if you have any questions or comments in the chat box, or raise your hand or let me know that you'd like to be unmuted. And I think we can unmute some folks and have some discussion. I'll just get us going as people are maybe typing in their thoughts. One of the things that Lance mentioned shortly before we got on the live session was the sort of the market scenarios for the phosphorus cake that is being produced. And I think that's really interesting. We, as a state, are still importing quite a bit of phosphorus. And so how do we shift that? And I'd love to hear if Vanguard Renewables has been thinking about how to, how to capture some of that market share in terms of local phosphorus instead of imported phosphorus fertilizer.
You want me to take it?
Yeah, go ahead.
Yeah, sure. So we're actively exploring different options. It seems like we're going to be producing enough that the people who are interested in it, actually, we're going to overwhelm them. So we're still actively investigating, and phosphorus being a finite resource, we want that to go somewhere where it'll be mutually beneficial, but there's still a lot to be spoken for. So as of now, the farm can use so much. There's some composting facilities that do have interest in it. But yeah, it's open right now as far as possibilities, for sure.
The system's oversized. It's actually larger than what we need, so that we can capture, as Lance mentioned in the video, up to 80% of the phosphorus that's coming through the digestate. And the farm does have some capacity to take on some phosphorus into the soil as part of their nutrient management plan. But obviously there are places around the state that have oversaturated phosphorus, and we have the challenges that we're faced with. So if it's in line with the local soil, the local agriculture nutrient management plan, then there will be opportunities for us to divert some of this phosphorus cake to other areas, but probably not going to ship it too far.
Makes sense. We have one comment, or well, actually a number of questions have come in. So Elena says, thanks for that walkthrough. It was mentioned that the phosphorus cakes are taken off site. Just curious, where do they end up? So sort of continuing on this thread. Also, it was mentioned that the slurry digestate is land applied. How wet is it at the point that it's land applied?
So I think we kind of answered the phosphorus cake question more or less. So that land application, the effluent actually comes out being less than 2% solid. So it's very wet, which the farmers make it really easy for the farmers to spread unless it's a wet spring or something like that. But through that, primarily, well, we have the solid separation on the front end. So we don't, on the manure actually generates a lot of your solid content in the digester. It's still always going to be a liquid slurry. So we're actually looking at probably under 4% for total solids in the digester. And then after it goes through the DAF process, that's bringing it down to pretty low levels. So it's still nutrient rich, but the solid content is super low once it's land applied. Yeah.
Great. Billy, feel free to jump in if you want, but I'll just move to the next question from Josh Kelly. To create electric power, does the AD facility have an engine to combust methane on site, as well as to send clean RNG to the VGS pipeline?
Yeah, that's exactly what's going on here. So we're completely off the grid electrically, but we do have a combined heat and power that is run off the natural gas that we both put in the pipeline and produce here. So that's how that works. And then you saw the diesel standby just in case for some reason we have an emergency and the combined heat and power generator goes down. Yeah.
Great. And Jason says that this is a beautiful system. Who did you work with to fabricate and install the main components?
There's an array of engineers out there, but we've been working with CH4 biogas out of Canada in recent projects. Yeah, and a lot of the engineering's through them.
And the component pieces came from different parts of the world.
Right.
As Lance mentioned, the CHP system came from the Czech Republic. The gas upgrader system, at least part of it, came from India.
Great.
A lot of brilliant minds collaborating in the project.
Thank you. Kathy asks if you could share your plans for managing food processing waste, liquid from food manufacturers, and also food scraps.
Yeah, so we're already taking in tons of liquid waste and solid waste into the system. We just opened up actually in October and began to accept food waste material and slurry, as well as liquid from cheese processing, dairy processing, a lot of brewery waste, distillery waste, and then some solid waste coming in. Depends on where they are and how far away they are, what state the material is in, as far as if it's a slurry, a solid, or a liquid. But there are hauling partners that we have that are able to collect that material and then bring it and transfer it into the hydrolyzer tank. The system is pretty big. It is able to accept over 100 tons per day of food and beverage waste. So we're looking for more and more partners every day to help us meet that goal.
And I have just a quick follow-up on that, Billy. How are you primarily taking it from Addison County, or how far are some of the sources that you're bringing into your farm or
so
to
we
the
do,
digester?
Yeah, Addison County, of course, Chittenden County, Washington, and then we have some discussions with folks in other parts of the state as well. But we're obviously trying to keep the distance down because that increases the time and the hauling cost.
Sure. Thank you. Abigail says, this is very interesting, and thank you for sharing the video. I don't think I fully followed what happens to the methane, and could you explain that further?
Yeah. Okay. So raw biogas is typically where we find it is in the 60% methane range. And then you're looking around 30% carbon dioxide. You have varying limits of hydrogen sulfide and then a bunch of other constituents in the gas. And that is not what they consider pipeline quality. You could combust that in a generator and make electricity, but it's pretty dirty gas. So this is kind of a state-of-the-art thing, newer, the gas upgrading system, and it really just spared a lot of the details because it's very complicated. You're going through different stages of cleaning that gas. So like those huge vessels are pretty much just activated carbon, and it's gonna bind with the hydrogen sulfide. You have to get the moisture out, so that's where we're chilling the gas and condensing all the moisture out of the gas for a drier product going through the filters. And of course, it needs to be compressed to meet pipeline standards, because as we're producing it, it's really, those bubbles look full and it looks like a lot of pressure, but it's really not even close compared to a pipeline. So it gets compressed. And then I talked about the pressure swing absorption, which besides the H2S, it's really going to take care of a lot of that CO2 and the other minuscule components of the gas, when we end up almost 100% methane in the end. And that's what's required to be injected into a pipeline. So that's pretty much that. Hope that answers your question.
Thanks, Lance, so much for elaborating on that. Athena would like to know if you accept anything with the food scraps, such as soiled paper.
We do have a 1% contamination limit. So if there's contamination in excess of that, we do have to reject loads. Something that is compostable or otherwise could be repurposed. A lot of times, unfortunately, we can't accept it because the residency time for the material in our system is a lot lower than it would be in a compost system or in some other repurposing. Something like paper probably won't break down in 5 days or even 30 days. So we would work with the food waste provider, if that was a consistent contaminant, to try to find a different process so that contamination could be removed and diverted to another stream.
Great. And Billy, how do you judge that 1% contamination? Is it you just kind of eyeballing it, or how? I'm just curious how that. I mean, I know like when you work with a system, you definitely get a sense for what's a lot or what's a little. But I was just wondering if you had a system for that or a procedure.
Yeah, it's by volume, by weight,
Mm-hmm.
mostly by volume, because a lot of the contaminants are lighter materials.
Mm-hmm.
And Lance, unfortunately, has to be there to take the contaminants out of the screening system that you saw. So
Yeah. Yeah, we have that initial screen in the liquid unloading port, and then if it's questionable, I'll even go as far as grabbing samples throughout the load and filtering it and try to like extrapolate it. Are we even close? You know,
Mm-hmm.
if there is a visibly contaminated load, we're just like we can't do it, because if any of that was, we have a lot of the systems designed to remove contaminant before it gets to the storage and eventually field apply. But that's one of our number one concerns. God forbid you get plastic into your feet, into the farmer's field. It's like totally contrary to what we're trying to do here. So, yeah.
Mm-hmm. Great, thank you. Abby would like to know, at what percentage of the system's capacity are you currently operating?
we're still below 100% because the gas upgrader system is not yet interconnected. That process is nearing the end. We're getting close to the finish line, and we expect over the next 6 weeks, possibly sooner, but at least over the next 6 weeks, that we will be interconnected and we'll have commissioning, and we'll have dotted all the I's and crossed all the T's with our partner, Vermont Gas Systems, to be ready to progress to 100%.
Great, yeah.
I'd say from a gas production standpoint, I'd say we're about a third of our overall capabilities, which is pretty good for an October startup in one of these systems. So it does take months to ramp up the biology and get it really jumping in there. So I think we're right where we want to be.
Yeah, and I think that's great, especially considering the year that we've all just gone through. I know that's had a huge impact on, just getting parts and getting things together and people's schedules and availability. So that's great. Tom would like to know if you could compare the quality of bedding you previously used to the bedding you repurposed from the digestate, and the pros and cons of what you're experiencing.
So this farm actually was already making green bedding from their manure before we showed up. So in this farm specifically, there wasn't that big of a difference. We're actually still separating the manure prior to the digestion process, which is rather unusual for what we've done in the past. Most farms will actually install the separator post-digester. In our experience, every farm so far, I don't have specific numbers, but milk quality has improved. And that's just subjectively being told to me from the farmers. So unfortunately, I don't have numbers here to show you, but the most cases, they're going from sawdust bedding to the manure fibers, and that's the case. We've seen improvements. We don't get into the farms that bed with sand just because we can't have sand in these systems, but that's a whole nother conversation. So.
Great, thank you. Any other questions, folks?
No one wants to talk about crop yields or something?
Well, go ahead, Lance, to jump in while people.
Oh man, you just go down in the Connecticut River Valley in Western Mass, and you'll be so surprised at what's going on over there.
Yeah.
So when we do get past the pandemic, we do look forward to having the opportunity to have folks come out and walk around and see this project, and ask questions and smell for yourselves what a dairy farm is like with the presence of an anaerobic digester. So keep wearing your mask, keep safe, cross your fingers. We'll get beyond this very soon.
Great. Oh, we have another question from Brian asking if there are any major differences from your existing sites in Massachusetts from this site.
Yeah, the biggest difference is this is a renewable natural gas project. The other projects they're generating gas, but it's being burned to generate electricity. So those are interconnected. So this project actually is going to have a greater impact on the climate because we're replacing natural gas that otherwise would come from fracking and other sources with a renewable natural gas product that can be used for the same purposes that any other natural gas would be used. So the impact on the climate is rather significant. And Lance, I don't know if you want to add on to that.
No, yeah, I was just gonna say size. Like this is the biggest herd size we've been working with, and it's almost 3 times bigger. And that means 3 times more gas and 3 times more the impact.
Great. Emma would like to know how the project was originally conceived and launched.
So this project actually started at the Goodrich farm several years ago, or many years ago, and was not able to get out of the gate, wasn't able to be a successful project. The previous developer wasn't able to bring this to the finish line. So Vanguard Renewables came in, I want to say 4 years ago, and began the conversations with the Goodrich family about taking over this project. One of the reasons why the projects that we work with are successful is the previous model didn't work that well. In a previous lifetime, I helped to finance some anaerobic digester projects in Pennsylvania, and the responsibility was put on the farmer and the family to manage and run the anaerobic digester. And farmers have plenty to do without becoming experts in anaerobic digestion. So what Vanguard does is we partner with the farms and we provide them with a lease payment. We professionally manage and operate the digester system and the combined heat and power system. That's what Lance does so deftly over in Salisbury, so that the farmer doesn't have that additional responsibility. We work hand in hand with them. We have a partnership with them because they're so intricately connected, but they don't have to worry about managing and operating it. So I think that's one of the things that we do really well that really helps the farmers to have projects that succeed so that they don't have that additional responsibility.
Yeah, that makes a lot of sense. Dan would like to know if there are any food types that you cannot accept due to upsetting the bugs, and what are other materials that you're looking to avoid?
So the digester is just like any other stomach, only much larger. So we need to feed it a balanced diet. So we try not to give it a lot of sugars all at once, or just nothing but sugars, because it will just get very hyper and then want to take a nap. But we try to manage the foods that are going into it, the diet that's going into it. Obviously, there's a mixture of carbohydrates, fats, and as far as materials that we can't accept, we can't take a lot of glycerin all at once, or glycerol all at once. We can take it over time. We can, just like any other material that you're putting into your body, you can't oversaturate it with a particular type of material, not too many carbs, or you'll have some challenges. What am I missing?
I would just say cleaning products from maybe from a process, like any bleaches, disinfectants. It's the microbial population that we're trying to grow and keep growing stuff. Constantly testing stuff coming in to make sure there's no contamination like that. That's the only thing I'd say you don't want in there. Yeah,
and another aspect of professionally managing the digesters, we have a full-time biology team that looks at the biology of the digesters around the clock. And farmers obviously wouldn't have the time, the experience, or the tools available to actively manage those. So having 3 full-time biologists is a good way to help make sure that we're giving these digesters a balanced, healthy diet. And then if there are any adjustments that need to be made because they received a healthy dose of glycerol, or they got a whole lot of brewery waste all at once one day, we have a team that knows how to make those adjustments.
Great. Can you comment on the use of the gas during summer months when heat loads are less? And do you envision putting more of the gas into energies to create electricity during the summer when electricity use is still high?
I don't think that'll be reflected in this project. All the gas we're making is going to go into the pipeline regardless and be used regardless, and our electrical demand is going to be consistent despite the season. So I don't think that'll be reflected.
Okay. Thank you. And then up to how many tons of food scraps will you be able to accept daily eventually? And at what proportion of the manure?
So we're taking 100% or close to 100% of the manure, and that's about 100 tons a day. And this system is designed to take well over 100 tons a day of food waste.
So you can combine those at equal.
Maybe up to 200 tons food waste. I think at a minimum you want to be, or we would like to be, if at the farthest reaches of a ratio from food to manure, like manure has to be at least 20% of your loading, food and manure loading. But we're well over here, so we could not use all their manure. But I mean, I love adding more bugs to my digester, so I'll take it.
Great. And Jesse would like to know if Vermont Gas, was Vermont Gas keen on putting in a stop to accept your power?
Does it, by that, I'm guessing that you mean putting in an access point for the gas. And yeah, they've actually been great partners for us. I think a lot of the gas companies, Vermont Gas is one of the more progressive. Not surprising because we are here in Vermont and it's in the wind, it's in the water, it's in the food. But no, they've been nothing but great to work with, and they have a number of customers who have a very serious interest in renewable natural gas. And we're seeing this as a trend across the country and around the world, that the appetite for renewable natural gas has increased dramatically. And in this country has increased dramatically, especially over the last 6 months. So we know that that's going to continue. And I think the number is 15% is the expected amount of natural gas that renewable natural gas from food waste can provide to U.S. consumers, both commercial and individual consumers. So right now, we're not even a blip on the radar as far as the volume of renewable natural gas that we're able to produce and displace, but the capacity is for up to 15% of our natural gas needs can be met with renewables from food waste.
Great, thank you. Elena says, you mentioned farms in Massachusetts showing high crop yields from the digestate. Do you find that the cost of finished digestate is comparable to that of finished compost? And what are the incentives for farmers to purchase digestate over compost?
That's an excellent question, and I don't think I have a good comparison. Yeah, because the farmers in general, like these dairy farmers, since they have that cow manure to crop to feed the cow manure kind of thing going on, they're not bringing in compost per se. Some of them do a little bit of composting, but I don't have any reference to that correlation. But what we've experienced is increased crop yields because, I mean, the nutrient that's being produced is just far more balanced and versatile than the cow manure alone. So I'm not sure where to go with that in comparison, but.
No, that's fine. Thank you. Yeah, I'm seeing a little lull in questions here. We do have a few more minutes if anyone has a final question. I did want to just offer up to you guys, when you do get to the point where you're ready to have an in-person open house, please let me know, and I'd be happy to share that date and announcement with the participants here who may be interested in coming and seeing it all in person.
Oh yeah, we would welcome that. We want a big party.
Great. A big, maybe still socially distanced party, but it looks like you guys have space. So, another question. How have any haulers collecting residential or business food scraps partnered with you?
Yes, we do have partnerships with a number of haulers, chief among which is Casella.
But we haven't gotten too far into the residential yet, but I think eventually it's got to happen, right?
Yeah, and one of the challenges with the residential is the contamination levels and the biodegradable bags. And as I mentioned before, we can't accept the bags because the residency time in the hydrolyzer and the digester is just not long enough for those to begin to degrade.
Mm-hmm. That's a good point.
Yeah.
Great. Well, Billy, Lance, any final remarks you want to provide or say?
Go ahead, sir.
I would just say thanks for having us. It's been a pleasure to share the splendors.
Yeah, thank you, Natasha. Thank you for hosting us and for the summit so far. I mean, this has been great, and I look forward to tomorrow and the rest of the week. And if anybody has questions that you think of afterward, feel free to reach out to me. You can find my contact info on the website. Probably the easiest way is to look up foodwaste.com.
Great, thank you. And that's a great lead in. I'd like to just remind folks that our program does continue throughout the week, starting at 10 a.m. tomorrow morning with food scrap composting success stories from the field and continuing on throughout the day. And this is our first of 5 virtual tours we're doing. Tomorrow's virtual tour is of Wyndham Solid Waste Management District's compost facility down in Brattleboro. So we hope you all can join us for more of the program as we work our way through the week. And just a final note that you will all be receiving by email at the end of the week a single evaluation form. We do hope that you'll be able to take just a couple minutes to fill it out. Your feedback really helps us in the planning process. And with that, thank you so much, Billy and Lance, for making the video and taking time. And thank you to all the participants for taking time out of this somewhat rainy afternoon to check out what's going on with the Salisbury farm. Have a good rest of your day, everybody.
Thank you.
Thanks so much.